NASA says it has heard from the Voyager 2 spacecraft, which right now is in interstellar space.
Voyager 2, which NASA launched in August 1977, is no ordinary spacecraft. It's been over 47 years since it set off on its mission, and it's still making us think in new ways. Designed back in a time when modern technology was still just a dream, Voyager 2 has gone way beyond what anyone expected, exploring realms of space that were once considered unreachable. What makes this spacecraft truly extraordinary is not just how long it's been functioning, but the distance it has traveled to. Together, Voyager 2 and its twin, Voyager 1, have traveled farther from Earth than any other human-made object. Both spacecraft have passed through the solar system and ventured into interstellar space, which few scientists thought we'd ever reach in our lifetimes. The original plan was for Voyager 2 to explore the outer planets. Instead, it provided us with stunning images and invaluable data from Jupiter, Saturn, Uranus, and Neptune. But the real surprise came when it sailed beyond these giants into the great unknown, interstellar space, the vast emptiness between stars. And now, even after nearly 5 decades, Voyager 2 is sending back data that's revolutionizing our understanding of the cosmos. Recently, NASA announced that Voyager 2 had made a discovery that scientists once thought impossible. In the deep, mysterious realm beyond the solar system, Voyager 2 has encountered phenomena that challenge our current models of space. What exactly has this intrepid explorer uncovered? Let's dive in. Before we look at what Voyager 2 has found recently, it's important to understand the environment it's traveling through. At the moment, Voyager 2 is in a region called interstellar space, which is beyond the influence of our sun. It's a place where the solar wind, a stream of charged particles emitted by the sun, meets the interstellar medium, which is a sparse mix of gas, dust, and cosmic rays that fills the space between stars. The heliopause is the boundary that separates our solar system from interstellar space. For years, scientists thought this boundary would be smooth and static, like a shoreline where the sun's influence ends and the galaxy begins. But Voyager 2 has shown us that this boundary is anything but calm. As it turns out, the heliopause is actually much more turbulent and dynamic than we ever imagined. As Voyager 2 crossed the heliopause in 2018, it started sending back data that shocked scientists. The spacecraft picked up some unexpected fluctuations in particle density in interstellar space, which challenged previous models. Instead of finding a uniform, empty void, Voyager 2 picked up sudden spikes in particle density, followed by long stretches of emptiness. This suggests that interstellar space is a lot more complex than we thought. This finding makes us think again about what the heliosphere is and how it works. The heliosphere is the protective bubble created by the sun's solar wind. Scientists had always assumed that this bubble was pretty stable, but Voyager 2's data suggests that the outer edge of our solar system is filled with waves and ripples, potentially caused by interactions between the solar wind and the interstellar medium. These ripples could extend far beyond the sun's influence, and they could even shape the very structure of the space around us. One of the most exciting things about Voyager 2's recent findings is how they show us what interstellar space is really like. Previously, scientists thought that once a spacecraft left the heliosphere, it would enter a relatively calm, static environment. But Voyager 2 has shown us that the interstellar medium is anything but still. It's dynamic, with constant changes in particle density, magnetic fields, and cosmic reactivity. This is a really big deal because it challenges a lot of what we thought we knew about space. The data from Voyager 2 shows that the interstellar medium behaves in ways we didn't expect. The particle density rises and falls in ways that we don't understand. What's causing these changes? Scientists are trying to figure that out. Some think that these changes may be the result of shock waves from supernova that happened a long time ago. Others think that there may be unknown forces at play in the vast emptiness between stars. As well as detecting an increase in particle density, Voyager 2 has also picked up on an increase in cosmic rays, which are high-energy particles that originate from outside our solar system. Since it first crossed into interstellar space, the spacecraft has been encountering cosmic rays. The latest data shows that there's been a notable increase in their intensity. This suggests that Voyager 2 may be passing through a particularly active region of space, where there are more cosmic rays than we thought. These findings have got scientists wondering where these cosmic rays are coming from. Are they coming from a supernova far away? Or could they be the result of other, less well-understood processes in the universe? Whatever the answer, what Voyager 2 has found is changing how we think about interstellar space and the forces that govern it. The discoveries made by Voyager 2 also have a significant impact on how we perceive the position of our solar system within the galaxy. The heliosphere, which was previously thought to be a clear and distinct boundary, is now seen as a much more dynamic and turbulent region. This could change how we think about how the solar wind interacts with the interstellar medium, and even how space weather affects planets like Earth. Space weather is caused by the solar wind interacting with the interstellar medium. This can create shock waves and other disturbances that travel through the solar system. These can affect planetary atmospheres, magnetic fields, and even the climate. Understanding how the interstellar medium behaves could help scientists predict space weather events more accurately, potentially protecting Earth from harmful solar storms in the future. What's more, the data Voyager 2 has gathered could help us gain a better understanding of the boundaries of other star systems. If our solar system's heliopause is turbulent, it's possible that other stars have similarly complex boundaries. This could change how we think about how stars interact with the galaxy as a whole, giving us new insights into the structure and evolution of the cosmos. The discoveries made by Voyager 2 aren't just of academic interest. They could have real-world implications for future space exploration. As we look to send spacecraft even further into interstellar space, it's becoming increasingly important to understand the conditions of this vast and mysterious region. Voyager 2 has shown us that interstellar space is a lot more varied and dynamic than we thought. This means that any future spacecraft will need to be designed with these challenges in mind. Engineers will have to think about how particle density might change, the possibility of cosmic rays affecting the journey, and the chance of encountering shock waves or other disturbances. These factors could affect how spacecraft are designed, the types of instruments they carry, and how they communicate with Earth over long distances. On top of that, Voyager 2 has been going strong for almost 5 decades, which shows how well its design holds up and how clever the scientists and engineers who built it were. Future interstellar missions will need to build on what we've learned from Voyager, creating spacecraft that can survive for even longer in the harsh environment of deep space. The success of Voyager 2 also brings up some big questions about the future of human space exploration. Although Voyager 2 is a robotic mission, its findings will be vital for preparing humans for long-duration space travel. As we look to send astronauts to Mars and beyond, it's important that we understand how to protect them from the dangers of cosmic rays and other space hazards. The data from Voyager 2 could help scientists come up with better shielding techniques and other protective measures to make sure that astronauts on future missions are safe. The discoveries made by Voyager 2 could also have an impact on other areas of science and technology. For instance, cosmic rays are key to understanding high-energy particles, which are vital in fundamental physics. They can also affect biological systems, which has implications for fields like medicine and material science. Voyager 2's data could provide new insights into how high-energy particles interact with matter, leading to advancements in fields like radiation therapy or the development of new materials that can withstand extreme environments. The spacecraft's findings could also help scientists understand better how cosmic rays affect planetary atmospheres, which might show us more about the role these particles play in climate and atmospheric dynamics. On top of that, Voyager 2's discovery of the turbulent nature of the interstellar medium could have implications for our understanding of star formation. Turbulence is a key factor in how gas and dust clump together to form stars. Voyager 2's data offers a rare insight into how these processes occur in interstellar space. This could help scientists improve their models of how stars and galaxies form and evolve over time. As Voyager 2 continues its journey deeper into interstellar space, it shows us the amazing potential of long-term scientific missions. In an era where new technology is coming out all the time, Voyager 2 shows us that it's worth waiting for the right tools to be developed. For nearly 5 decades, it has been collecting data, and its most important discoveries are only now coming to light. The success of Voyager 2 also shows how important it is to invest in missions that can operate over long periods of time. While many modern missions are designed for short-term exploration, Voyager 2 has shown that some of the most profound discoveries come from long-duration missions that continue to collect data well beyond their original goals. As we look to the future of space exploration, it's clear that Voyager 2 will continue to inspire scientists, engineers, and space enthusiasts for years to come. It's still got a way to go, and who knows what new discoveries are waiting to be made in the vast unknown of interstellar space. One thing is for sure, Voyager 2's legacy will live on, not just in the data it has collected, but in the spirit of exploration it represents. It has shown us that the universe is far more complex, beautiful, and mysterious than we ever imagined. And as long as Voyager 2 continues to send its faint signals back to Earth, we'll be listening, eager to learn more about the great unknown.